Yes, and now we are back into the second part of our programming for the Plasma CNC Plasma machine using Fusion 360. But first, let's run through our previous profile just for a recap, and then so we can have a view of the comparison with the second profile that was designed inside Fusion 360. First, we have our geometry, our design in the imported into the Fusion 360 interface, and from the design tab or design section, we go to manufacture because we need to manufacture our design. Then we set up by setting our stock and selecting the dimensions of the stock relative to the dimensions of the geometry, the profile itself. We pick our origin, like I said, and from here we can edit the dimensions of the stock, select the height, which will be the same width or thickness rather of our material to be cut from. Click on OK, click on cutting. Since we are doing a fabrication cut, our tool, select tool, we come to Fusion Library, turn on all libraries, select our plasma cutter. It has its dimensions in inch or metric. I will go for the metric, click on OK. Then from here, I select the geometry, that's the parts to be cut. And selecting the geometry, I come to models in the manufacture or design tree, whichever you want to call it. I come to sketches under model, the name of the model, sketches, and I select the sketch. Now it selects all the sketch. Then I edit it from the geometry dialog box, and I ask it to start from either outside or start from inside. But I already said starting from outside is more of like the way to go, depending on the direction of the cut when you check it later on. And from there we can select our composition is always on left. I will want to leave on left, we'll preserve that, and here we'll work on our leading and our lead out to exit. Okay, then I believe that will do the job. So okay, now if you notice, this was actually starting from the main stock, so you can come back and edit and tell it to select start from inside. Okay, all right, good. Yeah, this is better. So it's leading in from inside the profile, which preserves our main stock, our main design. And if you notice, the path of cut is quite smooth this time. It's not randomized. Right, good. So okay, this was what I was saying earlier concerning the um, issue, the two-part issue. If the two parts is not aligning with what you have now, I asked it to start from inside, and I have this yellow two parts error from the setup settings in the manufacturer tree. So what I have to come and do here instead, like I said previously, is you can disable your leading and your lead out. Just disable them, or just you can just leave the leading and just don't worry about the lead out, just leave the leading. And when you click on OK, okay, that didn't fix it also. Still come back and select, okay, I mean deselect your leading. Let's see if that will fix it. All right, that's what that fixed it. So here I'm telling it not to bother leading in or leading out, right? So now the final part to complete our step is to turn this design into the G code, what the CNC machine would understand, to turn these settings into G code. So after this, remember we come from setup to cutting. The next is to, okay, before that you can simulate. Yeah, you can simulate your part of cut, but I don't have this machine installed right now, so I'm not sure if to simulate. Okay, here I will view stock. All right, good. Yeah, that's beautiful. So good, I can simulate this. So, and you would see how it goes from
Now, okay, this is the reason why I always advise to select your geometries one by one. Now, if you notice here, it's starting from the external cut, which is wrong. Your cut on the plasma machine has to start with the internal features first before going to the external feature. That is why you should always simulate, by the way. You should always simulate. So I'm going to exit simulation and I'm going to come back to my profile, my setup to the profile, and I'll work on the selection of the parts. So here, just gonna select these guys one after the other. Now, there is a way to go around the selection manually, but the reason why we can't use that method is simply because this design, like I said repeatedly, it's from SolidWorks. It's a DXF from SolidWorks. So the features of the parts, the design will not is not really um, detected efficiently by Fusion 360. So that is the reason why we can't use that feature. But there is another video after this. I'm going to show you how to circumvent that process instead of selecting one by one. If you have your design directly from Fusion, there's a way you can choose your features either internally or externally. Now, okay, I'm done with that. I'm just going to click on OK. It's going to process. Now we can tell it to simulate, right? Okay. Now watch this. It's going to start from the internal first. See? So it cuts through the internal first, preserving our parts, the parts that was selected, preserving that part. I can make this go a bit faster. Yep. So you can see after cutting through the internal features, it comes out to cut the external features and it is done. That is exactly what we expected. That is what we wanted. Now we exit simulation. Now from here, when you're done simulating, then you come to what we call post-process. That is what turns your program into your settings, your setup into the G code. Now you can see down here at the right hand side corner, downward, you can see your machining time, the time it will probably take to cut this piece. Sometimes, most of the times, it's quite accurate, actually, from experience. Now I've clicked on the post process and I am here in this dialog box. And what I am going to do is to first select a post processor, which is very important. Post processors are what will allow us to be able to convert it to GPU code. Now, if I post right now, if I post, it's going to bring an error because we don't have the post processor selected. So what I'm going to do is select post processor. I'm going to go to my post local and I'm going to import a post processor. Now, post processors are everywhere right there in um, the Fusion, Autodesk library website. There are quite a number of post processors. You can just search it on Google. Post processor for either plasma, laser, water jet additive. There. So this is a flash cut plasma post processor, CPS, is exactly what we need. So another thing I should show you is, okay, let me import the second one. This is for milling, by the way. So I have two post processors, one for milling, one for plasma. Now you cannot use the milling post processor for a plasma operation. Let me show you. Now if I try to, now this should be bottom body or thereabouts, body from 1 mm times 1. All right, now if I try to post process this, let's say I'm post processing into documents. If I try to post process this, I'm going to see a field right here at the bottom right hand side corner, right? That means I'm using the wrong post processor. So instead, what I am going to select is the plasma post processor, and I'm going to select the folder I want to post process into, right? So, right. Okay, that should be it. Sorry, bottom body, 1 mm, just one piece. Just one piece. Now if I post, you see successful. Now you can view your NT code if you have a note editor or you have a Visual Studio Code recommended. So most of the time, the program just launches your Visual Studio Code automatically. So, but here I'm going to stop it from downloading Visual Studio Code because um, I don't need it. But you can use it to view your G code. Now that's about this profile, this design, this cut. Here we are going to be talking about the second part of programming for a CNC Plasma machine using Fusion 360. I have this design here in my workspace, and what we are going to do is convert this design into a flat pattern that can be used, that can be cut. Now, this is more of like a flanged body, and having a thickness of about 1 mm. I want to cut it from the plasma, thickness of 2 mm rather. Let me see if I'm correct. It should be 2 mm, correct. Now, what we will have to do first in uh, cases like this is to get the flat pattern. So we come to sheet metal. The first thing is to convert to a sheet metal. Okay, first let me see if I can go through that process again. I already did it. Yeah, it has been converted to a sheet metal. Yes, it has been converted to a sheet metal there. So if you come to sheet metal and you first convert to sheet metal, you convert your profile to a sheet metal. If you don't convert it to a sheet metal, it will not post process. It's not going to be converted into a flat pattern, rather, not post process. It will not be converted into a flat pattern. So from sheet metal, come to create, and come to create flat pattern. Then I select my stationary face. This is where I want to be stationary. And I click on OK. Exactly. That is what I want. So it is converted into a flat pattern, and all the flanges and everything is um, spread out and defined. So the next thing to do here is to export the flat pattern as a DXF. So I come to export flat pattern as DXF because I need it as DXF in order to be able to post-process it, to work on it. So I want to save it in cloud. I, I don't want to save it on my computer. So internal geometry version 1. So as DXF, then I click on save. Now if I come to the data panel here, I should see it's been uploaded. Takes a while. That's for Fusion. Anyways, now from here, I should also state that there are other ways you can actually um, extract your sketch, but that is not what we need to do today. The main information we need is creating this flat pattern from the main profile so we can get our 2D profile for us to be able to program and cut from, right? Exactly. So let's wait for that to be processed. And now we have it in our data panel. And from here, we can create a fusion design from it. After we create a fusion design from it, then we can proceed with our programming. There we have our fusion design from the flat pattern we created. This is the flat pattern DXF, and this is the fusion design. So normally if you import a DXF from external CAD files, like other CAD files, sometimes you get this, then you can create your fusion design from there. Here we can click on create flat pattern, finish creating flat pattern rather. So now you can notice the sketches that were made in creating this design here. They do not have the flanged profile on them. That is the reason why we have to first turn this design into a flat pattern before proceeding to program. Now we have to launch our Fusion design that we created from the flat pattern. And there we have it. Yep, exactly. So if you notice, there are some profiles here, some geometries that seems to be like a line. Now these are our bend lines. They are called bend lines. These are useful when you want to make drawing files from this design. It informs you on where to bend, the distance and the dimensions to use in your bending, the length and everything. So you can see all this. All these were not in our previous video that we did when we imported a DXF file from SolidWorks. This was not included. You can see outer profiles, interior profiles, bend lines. These are the bend lines. You see, selected the bend lines only. This bend line and bend extents. All right. So now those will come in handy later. So from there we come to manufacture and we go through the same process. The only difference this time is being able to select our geometries faster and more efficiently. Of course, I have explained how you set your stock. It has to correlate with the dimension of your main design. If you look at this, this is more of like overlapping the main design by a little distance, which is good. The stock should overlap your main design, your main profile, your main geometry. You can select the thickness, which is the height, Z. It's okay for 1 mm, but I'm cutting from 2 mm this time, so I would select 2 mm. Okay, oh, it says no model selected, blah, 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 blah. Yeah, you can just proceed. It will select this model. As the reason why it says that is because I've not, okay, it has selected already. So you just click on yes, and it will select the model. Now, from here, we proceed for our cutting setup. So now, initially in the first video, I explained how you select your tool here, but I'm not going to select it this time. I'm going to show you something. Now, even if you don't select and you proceed with your selection of your geometries, right? Now, in the selection of the geometries, instead of selecting all these profiles one by one, imagine the first video I did look at the number of internal geometry that was present. It took a while to be able to select them all through. And there are times you might even miss some geometries. You might miss because of how small they are. You might miss them out, or probably because they are quite much. So it's not efficient to go around selecting each and every geometry one by one, by the way, but it is good. It's a trade-off. It is good to select your geometry one by one at a time so you can preserve your order. Like I said, it's good to cut the smaller ones first before the bigger one for the internal geometries. It comes in handy when you select them one by one. You can preserve your order of selection and tell the machine, this is the part I want you to cut through. This is how I want you to cut this one after this one. So here now we are going to come to models, the name of our model, then sketches. Then we are going to select our interior profiles. It's going to select them automatically. You can see selected all the interior profiles only. And from here, we can tell it to start from inside the interior profile or outside. We are going to see that when we want to simulate. But here first, we tell it to start from inside. Then we can edit this and we can rename this interior, right? Good. This is our interior profile. Now the next one is to select our outer profile. Now the outer profile is just the extent of the design, the outer design, the outer sketch, the main sketch of the design. You understand? So if you select this, it's just going to select the outer sketch. It's not going to select the lines in between. No, it's just going to select only the outer sketch. It is not going to select the lines in between. Now, I'm going to ask it to start from outside, which is okay. Now, I'm going to rename this out, right? Good. So from here, I'm done with internal, internal profile. Okay, let me rename this as in, and out. Better. From here, we'll deal with our clearance side, retractile. Like I said in the previous, I don't really touch this much. I leave this alone now. I preserve order also. And here I can leave my lead in and lead out. I believe it should work without any issue. Now, if I click on OK, you see, you remember I didn't select any tool initially. Immediately I clicked on OK, it brought the tool dialog box that I have to select a tool. I'm going to come to Fusion Library for the metric tool, which is in mm. I'm going to select that. And there we have it. It's post-processed. Now, if you look at our lead in and lead out, it was from the inside of our stock, which is exactly what we want. That is how we want it. Now, let me show you something. If I come here and I extend my lead in and lead out a bit, let's say to about 3 mm, the lead out also to about 3 mm. Good. Now watch this. It's cutting, it's leading in from the part of the stock we want to discard. We don't really need, right? That is exactly what we want. And it preserves our main profile, our main stock. That is for the internal features. Look at this circle here. It leads in from this guy. This guy, it leads in from the left-hand side, which is good. It preserves our main stock. If you look at the outer wall, you see, it leads in from the external part. It leads in from the right side into the cut, preserving our main stock. That is exactly what we want. And if you notice, the bend lines are not touched. They are untouched. We are done with that. And from here, we can come to the section of the post-process. Let's simulate first so we can see what exactly we're doing. Now, if you watch, it will cut the internal first, internal. Now, notice it's quite randomized, right? It's because we didn't specifically state that this should be the order of cut, because we have to select all the geometries at once using internal, interior profiles, outer profiles, you understand? That is the reason why we don't have a specific order in cutting it. So the computer Fusion 360 rather, just decided to go about a path to cut on its own. But it comes in handy because we are able to select multiple profiles at once simultaneously without having the need to go about selecting them one by one. So we're done with our simulation. You can see it cuts the internal profiles first, then cuts the external profile. Can exit a simulation. That is what we want. It's beautiful. Now from here, we can go to post-process. We have our post-processor selected, our CPS file. Then we can rename this as internal geometry, right? Internal geometry. From 2 mm, there's one. And we can post-process that. Now, I didn't talk about these settings in the other video. The reason is because I just leave them the way they are. I don't really touch them. I don't deal much with G-code itself. I believe Fusion 360 has every needed settings and parameters covered in creating the G-code, since the processor I'm using is in line with the kind of machine I want to use, in line with the kind of operation I want to use, which is plasma cutting, right? Now we post-process and we have a successful post-processing. Now from here we can take our file to the machine to cut.
Hey everyone, now we'll be cutting our part from the 2 mm plate, and hopefully the geometry we selected as internals first will be cut from the inside, then external geometry profiles will be cut from a leading externally. So we can go into our files, the USB and machines. Then we have our 2 mm internal geometry. This is what we want. Now, I would like to make mention of something quite important. We'll be cutting from this little piece right here, but because the orientation of our plate is like this, we might not really get what we want fully from it. So I'm going to be turning the orientation this way instead. So from horizontal to vertical. And that will be made possible by coming to part options. Now, if you would notice, the origin starts from here, right? I'm going to rotate this so the origin will come here. I mentioned in my previous videos that for the array and rotate, the part options, the rotate function, rotate counterclockwise in the positive degrees. So 90 degrees rotates anti-clockwise, making the origin move towards the right hand side. So I rotate F2, shape rotate 90 degrees. Now look at that. We have our origin moved to this side. So let's move our nozzle. Okay, first I have to press escape. Good. Then I move to this side and bring the nozzle down. Okay. Yep. Let's see. From there, you can click on manual move, then frame. There we go. There we go. There we go. Now I can shift a bit. Yep. I'm satisfied with that. I can resume and it will tell me to modify the reference point I just shifted the nozzle to. Press enter and there I have my origin where I want it. Now if you look closely at the profile here, you will notice that the internal profiles are having their laid out internally. It's shown right there, you can see it right there. And the external profile having its leading laid out external. That is what should happen. That is exactly what we want. Now let's get to it. Oh, we're cutting from 2 mm. Sorry, we have to modify our cut speed, which should be 1800 for this old nozzle. I'll leave all these here as they are. The hub voltage 105, PS time 0.03, 0.3 rather, PS height 0.06, and initial height sensing time 0.03. Correct. And I have my current set to 32, to 33. Alright, good. Speed, all set, check. Controls, check. Alright, let's get it started. Good. Whoop. There we go. Oops. Oh god. I have to stop that now and I think I'm gonna have to shift the plate. So I have to bring the nozzle up. Bring this out right here. Take this out. Yep. I am gonna have to shift the plate. Yep. Which means I am gonna have to take a new origin. Okay. Now I take this back a bit. I need this guy also to come. Yeah, stay right here. I need this guy fixed. So fixed. This will be my new origin. Yes, a new orientation. Yep. Yeah, that's what I want. Take it up. I stop my previous cut, says end cutting. Tell it yes. Okay. Then bring it towards here. Manual move a frame. Yep. Okay. I'm satisfied. Let's go. Hope it doesn't shift again. Okay. We're good. We're so good. Yep. Now that's gonna follow, I promise. With the last internal profile, I'm correct. And we have external profile. Got. Yep. Cool. There we have it. We're done with the cuts to home. Just escape is enough. Escape will do. I need to bring the nozzle out of the way. Good. Then, gently knock this guy off. Knock this guy off. Then gently bring this guy out. Or just knock this guy in also. And let it come out. Split is quite really hot. Okay, I think that's better. Yep. Yep. And there we have it. Quite some thick slag there. Well, cheap enough will do the job. Okay. Yep. There are some tiny profiles here that the plasma didn't do justice to it. Okay. Thank you everyone for sticking by till the end. Catch you guys on the next one.